This is the brief on MIT's new self-organizing laser. So, a recent Nature Methods paper just revealed how researchers pushed a laser to its absolute breaking point, accidentally unlocking a revolutionary, high-speed way to look inside the human brain and test drugs. First, let's look at the physics breakthrough. MIT grad student Hung Hao Kao pushed a standard optical fiber basically right to its damage threshold. Normally, extreme power creates chaotic light, right? But if it enters at exactly 0 degrees, it miraculously self-organizes into a stable pencil beam. It's literally like cranking a fire hose to maximum pressure and instead of a wild spray getting a perfectly smooth, needle-thin stream. Second is the imaging leap. This precise beam generates 3D cellular-level images of the human blood-brain barrier 25 times faster than standard methods, totally avoiding those annoying blurry halos. So what does a perfectly clear, super-fast laser actually do for us in the real world? Finally, we get to the real-world medical impact for diseases like Alzheimer's and ALS. By skipping cumbersome fluorescent tags, researchers can watch experimental drugs enter human brain cells in real time. Animal models notoriously fail to predict human reactions, you know? We aren't taking static pictures anymore. We're watching a live-action movie of potential cures. By pushing a laser past the traditional rules of physics, MIT hasn't just built a better light bulb. They've given us a real-time, ultra-fast window into the brain that could accelerate the cure for our most complex diseases.